Okay, let's do the review. We've got a slope already, so I don't know why I did that. Y minus 4 equals 3 over 2 x minus 6. Now, once we have that, we can multiply this through. So we would get y minus 4 equals 3 over 2x. And then that would get us 3 over 2 times 6. That would go in there. So that would get us minus 9. So then you add the 4 to the other side. And then you would get y equals 3 over 2x minus 5. And then if I wanted to put it in standard form, I multiply everything by 2 and get this. I subtract the 3x to this other side. Oops, I forgot the 2. Y equals negative 5. But I don't want that to be negative, so I'm going to multiply everything by negative 1 and get 3x minus 2y equals 5. Okay, so let's do this next one. We don't have a slope, so I need to find it. So 4 plus 2 over negative 2 plus 3. So m is going to get 6 over 1. So that gets me 6. So either I'm going to do y minus, or actually plus 2 equals 6 times the quantity x plus 3. Or if I use the other one, it would be y minus 4 equals 6 times the quantity x plus 2. Okay, I'm just going to use the first one. So 6x plus 18. I subtract a 2 and I get y equals 6x plus 16. Then if I use standard form, I'd subtract that 6x. I get negative 6x plus y equals 16. Multiply everything by a negative 1, and I get 6x minus y equals negative 16. Then, parallel means they have the same slope. But first I have to solve for y in order to know what that's going to be. I subtract 3x. I get 2y equals negative 3x plus 11. Divide everything by 2. Y equals negative 3 over 2x plus 11 over 2. So the slope that I'm going to be using is negative 3 over 2. So y minus 7 equals negative 3 over 2 x minus 9. So then I have y minus 7 equals negative 3 over 2x plus, what is that going to be, 27 over 2. That's not real nice. So I add 7 to both sides. I get y equals negative 3 over 2x plus 7 over 2 is the same thing as 14 over 2. So that would get me 41 over 2. Oh, that goes right there. Then if I want that to be in standard form, multiply everything by 2. Oh, you know what? Let me write this down here instead of doing that so that I can use, because I want to multiply this all by 2. And I would get 2y equals negative 3x plus 41. Add that 3x to the other side, get 3x plus 2y equals 41. This one, perpendicular. That means my slope is the opposite reciprocal. So that means I'm going to get negative 3. So y minus 4 equals negative 3 times the quantity x plus 3. I'm going to multiply that through. So I get y minus 4 equals negative 3x minus 9. Add 4 to both sides of the equal sign. Get y equals negative 3x minus 5. Then move that negative 3x to the other side and get 3x plus y equals negative 5. Okay, this one. Again, it is parallel. So I get 3y equals negative 4x plus 1. Divide by 3, divide by 3, divide by 3. Y equals negative 4/3 x plus 1/3. So parallel means that I'm going to have m equals negative 4/3. So that's y minus 7 equals negative 4/3 and x minus 12. Okay, multiply that through. Y minus 7 equals negative 4/3 x and 4/3 times 12. That goes in, that would be 4, so that's plus 16. Add 7 to both sides and get y equals negative 4/3 x plus 23. And last but not least, I'm going to multiply everything by a 3, so I'm going to get 3y equals negative 4x plus, multiply that by 3, and I'm going to get 69. Add that 4x to both sides, so 4x plus 3y equals 69. Okay, next one, perpendicular. Opposite reciprocal, so negative 6/5. So that's going to give me y minus 2 equals negative 6/5 and x plus 10. Then I'm going to multiply that through. Y minus 2 equals negative 6/5x. And that's going to get me minus 12. Oops, I don't know why I have that parenthesis there. Oh, I do know. Oh, no, I don't. So x is going to be minus 12. Add 2 to both sides. Get y equals negative 6/5x minus 10. Multiply everything by 5, and I would get 5y equals negative 6x minus 50. Add the 6x to the other side. And voila. Okay, so this one, it says solve, write set builder notation and interval notation. So I'm going to subtract 7 from both sides and get x is less than negative 10. And then that would be negative infinity up to negative 10. And negative 10, negative 9, negative 8, 7, negative 6, negative 5. Okay, open dot, and it's all the numbers less than. Okay, next one. Divide both sides by negative 3. I get x plus 4 is greater than or equal to negative 2. Subtract 4 from both sides, and x is greater than or equal to negative 6. So then that means x such that x is greater than or equal to negative 6. Oops. And that would be from negative 6 up to positive infinity. Negative 6, negative 5, negative 4, negative 3, 2, negative 1. That is a closed dot, and it's all the numbers up above. Okay, Subtract 5 from both sides. Get 3x is not equal to negative 3. Divide by 3. X is not equal to negative 1. So 0, 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. Cannot be equal to negative 1, but it's equal to everything else, both above and below. This one, I add 4, add 4, add 4. Oh, sorry, I forgot to do set builder. And then it would go from negative infinity to negative 1, union, negative 1 to positive infinity, but it doesn't count negative 1. Okay, so this would be 11 is less than or equal to x, which is less than or equal to 1. Guys, when is 11 ever less than 1? No solution. Okay, this one, I'm going to add 2 to both sides, or all 3 sides. That's going to get me 0, x minus 1 is less than 15. Divide everything by 3. 0 is less than x minus 1, less than 5. Add 1, add 1, add 1. I have 1 is less than x, which is less than 6. So, nope. So open dot at 1, open dot at 6, everything in between. Set builder notation, 1 less than x, which is less than 6. And net are from 1 to 6. Awesome. Add 4 to both sides. Get x is less than or equal to 9, or divide by 3 on both sides. X is greater than 12. So set builder, x is less than or equal to 9, or x is greater than 12. So negative infinity up to 9, union 12 up to positive infinity. So, I don't know, 10, 12, 13, 14, 9, 8, 6, 5, 4. So close dot at 9 going downwards, open dot at 12 and going upwards. Okay, this one. Less than, so this is going to get me negative 3, less than or equal to x minus 7, less than or equal to 3. Add 7, add 7, add 7. I get 4 less than or equal to x, less than or equal to 10. So it goes from 4 to 10. And 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Goes from 4 to 10. Okay, this one, I add 2, add 2. This is positive, less than negative, so no solution. Okay, next, subtract 3, absolute value of n minus 7 is less than 8. Less than, so negative 8, less than n minus 7, which is less than positive 8. Add 7, add 7, add 7. Get negative 1 is less than n, which is less than 15. Negative 1, 1, 2. Okay, open dot, in between, open dot. That was a horrible brace. N such that -1 is less than n, which is less than 15. I'm going from -1 to 15. Okay, subtract 1 from both sides. I get x minus, oops, that's not minus. 8 absolute value over 4 is greater than or equal to 1. Multiply both sides by 4. X minus 8, absolute value of x minus 8 is greater than or equal to 4. Greater, so x minus 8 is greater than 4 or equal to 4. Or x minus 8 is less than or equal to -4. Add 8 to both sides. Get x is greater than or equal to 12. Or add 8 to both sides. X is less than or equal to +4. So 3, 4, 5, 7, 8, 9, 10, 11, 13. So it's less than or equal to 4. It's greater than or equal to 12. So x such that x is less than or equal to 4, or x is greater than or equal to 12. So we are going from -infinity, oops, that's 8, not infinity, to 4, union 12 to +infinity. Okay. Shauna solved the math problem below and wrote her answer in interval notation. Is Shauna correct? Okay, so this part, we've got an OR going on, so that's union. She added 3 to both sides. Divide by -7. When you divide by -7, you change the inequality. Okay, so okay, so if I was going to write this in interval notation, -infinity to -2, union 3 to +infinity. So let's look. Yeah, her answer was correct. Okay, Tracy was really hot at our softball game. She yelled, it has to be at least greater than or equal to 110 degrees today. First, specify a variable. Let x equal the temperature. Okay, then write an inequality. X is greater than or equal to 110. Okay. The football team is selling raffle tickets. To motivate more students to buy tickets, they're giving discounts to anyone under 18, less than 18. They also want to give discount to anyone older, probably less than or equal to 18. No, it just says under. Or anyone older, 60 and older. So X is greater than or equal to 60. Oops. Let X equal the age of a person. Okay? So we're going to put 18. No, we're not going to do 18. Oh, we'll do 18. We'll do, actually, let's do 15, 20, 25, 30, 35, 40, 45, 50, 55, 55, 60, 65. So it's this and older, and this, which is 18 and younger. Come on. There we go. Okay, so now we're going to graph these. So my y-intercept is -1. I have a slope of 2. Put arrows, and it says greater than. So it's going to be up here. If you need to do a test point, 0 is greater than or equal to 0 minus 1. That is true. Here, x is equal to something, so that means it's a vertical line. 1, 2, 3, 4, 5. It's this line right here. And it says greater than, so it would be everything over here. Okay, so this next one, we have an open dot at -2. We go up 1, 2, 3, but we went negative direction. 1, 2, 3, negative direction. 1, 2, 3, negative direction. And it would be this way. If I use 0, 0, 0 is less than 0 minus 2. Is 0 less than -2? No. It's a false statement, so that means this point right here would not be a solution. Okay. Okay, over here, I have 2, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. Okay, and it would be greater than. And if you wanted to use 0, 0, 0 is greater than or equal to 0 plus 2. Is 0 greater than or equal to 2? Nope, that's a false statement. So that's why it's graphed on the other side. Okay, this one, I need to subtract x from both sides. -y is greater than -x plus 3. Divide by a negative, divide by a negative, divide by a negative. I get y is less than x minus 3. So I go down to -3. I have a slope of 1. Like so. It says that it is less than, so it will be down here. If I picked 0, 0, 0 is less than 0 minus 3. 0 is less than -3. That is a false statement, so that point is not shaded. So y is equal to -6. 1, 2, 3. I think I'm going to have to go by 2's. So 2, 4, 6. That is a dotted line and all the numbers less than. So down there. Okay. So this one, I'm going to subtract 2x from both sides. -3y is less than or equal to -2x minus 12. Divide by -3, divide by -3, divide by -3. Y is greater than or equal to 2/3 x plus 4. So I go up to 4. Jeez, it's loud today. 1, 2, 3, down 2, go over 3, like so. And it says greater than, so it would be up here. So if I was to plug in 0, 0, 0 is greater than or equal to 0 plus 4. That is a false statement. This one, I'm going to add 4y to both sides. I'm going to get 2x plus 4y is greater than 16. Subtract 2x. 4y is greater than -2x plus 16. Divide by 4. And I get y is greater than -1/2 x plus 4. So 4 is, oops, that is not a solid dot. It is a open dot. Down 1 over 2, down 1 over 2, and like so. It is greater than. If I was to plug in 0, 0, I would get 0 is greater than 0 plus 4, and that is a false statement. Okay, come on. Okay, what satisfies this? So my y-intercept is 4. My slope is negative. And I go down 1, 2. Oh no, these are going by 2s. So 2, 4, 5. So negative 5 over 2, 4. And that's y is greater than. This one, my y-intercept is at negative 1. Then my slope is 2 and 2, 4. Negative 2 over 4, so that's negative 1/2. Y is less than. Okay.